Welcome to The Explainer. Today, we're going to crack a common kitchen mystery, one that you've definitely run into but maybe never really thought about: the weird physics of pasta.
So let's dive right in. You've been there, right? You grab a single, dry stick of spaghetti, you hold it at both ends, and you bend it till it snaps. You're expecting a clean break, but nope. You end up with 3, 4, maybe even a bunch of tiny pieces. What is going on?
Well, if you've ever been stumped by this, you're in some pretty amazing company. Turns out, this little kitchen quirk was a real head-scratcher for one of the greatest physicists of all time, Richard Feynman. It's a problem that looks simple, but is actually incredibly complex.
So what's really happening when you put that pressure on a brittle little rod like a piece of spaghetti? Well, the whole story starts with a basic concept that applies to all sorts of materials.
See, every brittle rod, whether it's pasta or, say, a carbon fiber tube, has a breaking point. Physicists call this its limit curvature. It's basically the absolute maximum it can bend before the stress inside just becomes too much and it has to give way.
So when you bend that spaghetti past its limit, it snaps. And that first break happens exactly where you'd think, at the weakest spot along the stick, probably where there's some tiny, invisible defect. Okay, so far so good. Makes perfect sense.
But here is the crucial thing. That first snap, it's not the end of the story, not even close. In fact, it's the beginning of a really violent, super fast chain reaction that zips through the pasta.
The second that spaghetti breaks, all the energy you put into bending it gets released in an instant. This creates this powerful rebound, like a shockwave of energy that scientists call a flexural wave. And it travels back down the pieces you're still holding at lightning speed.
And incredibly, thanks to high-speed cameras, we can actually watch this happen. What you're looking at here is a bent spaghetti rod at the exact moment one end has been released, basically mimicking that first break. Just a few milliseconds later, you can literally see that flexural wave traveling from the top end that was just let go down toward the bottom end that's still clamped. The pasta is trying to spring back to straight, but it doesn't do it all at once.
And check out what happens as that wave keeps going. It doesn't just pass through. It actually creates a brand new, even sharper bend further down the rod. You can see it right there, a new zone of extreme stress caused by that rebound wave. And this leads us to the most counterintuitive, just plain weird part of this whole thing. It's a twist that seems to defy all logic at first.
I mean, our common sense tells us that once the thing breaks, the tension is gone. So the pieces should relax, right? They should become less bent.
But the physics here is wild. That rebounding wave actually overcorrects. It causes other parts of the spaghetti to bend even more violently than they were just before the first break ever happened.
And this isn't a tiny effect. The research showed that this wave can momentarily ramp up the curvature somewhere else to almost 1.5 times the original breaking stress. Think about that. The rebound is actually more powerful than the initial bend you put into it.
So, what happens when a section of that rod suddenly gets bent even more than the stress that caused the very first break? Yep, you guessed it.
It sets off a domino effect, a cascading failure. The first break sends a wave that causes a second break, and then that second break sends out its own set of waves, which can cause a third and then a fourth, and on, a whole avalanche of fractures in just a few milliseconds.
And this image shows the result perfectly. This is that same piece of spaghetti from before, just a moment after the high-speed camera saw that wave. It broke again, right at the spot where the wave created that new, super intense bend.
Now, this isn't just some clever theory. The scientists who figured this out were incredibly meticulous. They proved it by putting their mathematical models to the test against what actually happens in the real world.
And here you can see the theory meeting reality. On the left, that's the real spaghetti from the high-speed footage. On the right, that's the computer model predicting where the most stress should be. And look at that, it's a perfect match.
And this wasn't just a one-time thing. They ran the experiment 25 times, and you can see here, every single break, each one of those dots landed exactly inside the high-stress zones that the theory predicted. The model just worked perfectly. The proof, you could say, is in the pasta.
So the huge takeaway here comes right from the research paper itself. And it's this kind of mind-bending idea. In the weird world of physics, releasing stress in one spot can dramatically and instantly increase it somewhere else, triggering this cascade of failures.
You know, finally understanding the hidden physics inside something so ordinary, something right there in our own kitchens, it really makes you wonder, doesn't it? What other amazing, invisible chain reactions are happening all around us,
just hiding in plain sight. What other secrets are just waiting to be cracked?